Okay, so we will go ahead and get started. These are previous parent functions that we've done. We have our constant function. It could be f of x or it could be y, yes? These are just, I just put them all in function notation. We have our constant, we have our linear, we have our quadratic, our absolute value, our cubic function. I wrote the square root and the cubed root in fractional or rational exponential form, just because it was easier to put up here like that, okay? When we actually studied it, we had f of x would equal, oh, I guess I didn't unfreeze it, would equal the square root, and actually had the square root of x here equal the cubed root of x. I just wrote it like that just because it was easier for me. Now, I put all this down here and I just used the quadratic as an example. Your A, this right here, determines your vertical stretch or shrink. Your H determines your horizontal shift. And remember, when we talk about horizontal shift or vertical shift, we don't say it, horizontal shift of a -3. We would say a horizontal shift left 3. Everybody with me? Yes, no, or maybe? And just like our vertical shift, we would have a vertical shift up or down of however many units it is. Don't forget about our vertex. Our vertex is either our turning point or in our parabola. It either opens up, our vertex is our max or our min, or it opens down, okay? When we start talking today about our square roots and our cubed roots, even our fourth roots and fifth roots, even those, okay, you have a starting point. You don't necessarily have a turning point, okay? And of course, not everything has our axis of symmetry, but in this case with the quadratics, axis of symmetry is x equals h. So we have all of this. All of this we've done, all of this that we know. We've done it before, it's in your journals. Now, this, can't see all of it, this is the exact same thing, except they're giving it to us in radical form. Everybody with me? Yes or no? So if you actually got onto your online books in section 5.3, don't know the page number, it's right there. So if you wanted to look that up, because there's a link on the website, you can. Everybody with me? I'm just bringing this all back to your recollection. This is the same exact thing that we learned. Everybody there? We're expanding it by talking about fourth roots and fifth roots. Everybody with me? And of course above. All right. So if I look at this one right here, let the graph of G be a horizontal shrink. Okay, so we have a horizontal. Now let's talk about let me go back one. Let's talk about the horizontal. We're used to vertical. Everybody with me? If this had talked about vertical, and I'm going to make up something. Everybody with me? Okay, so I'm going to say f of x equals, and then I'm going to say we have a vertical shrink. That means my y values get smaller, yes? Okay. A vertical, we're going to say vertical right now, of 1/6. Then I would have 1/6 times whatever. Everybody with me? But when I'm talking a horizontal, don't forget, when we're talking horizontal, we have f of x equals, and then it's going to be grouped with x. Everybody understand? And when it's grouped with x, we use the reciprocal. Everybody with me? Okay, a prime example would be back here. We're talking about a horizontal stretch or shrink. Emphasize this right here. Horizontal stretch or shrink. It's grouped with x, yes or no? A shrink by a factor of 1/3 means I would group it with x and use the reciprocal. Everybody there? Remember? Okay, we didn't emphasize it a lot, but we are going to be working with it a lot now. Okay, and again, a stretch, a horizontal, I want to emphasize horizontal, a horizontal stretch by a factor of 2, the reciprocal of 2 would be 1/2. Everybody with me? Questions here? Okay, so we go back here. Let graph of G, we're going to stick with a horizontal shrink. So right now I know something's grouped with X, yes or no? What's going to be grouped with X?
1/6.
So,
Reciprocal.
okay, what's the reciprocal of 1/6?
6.
6. So whatever it is, whatever, did they say G? I need to use G. So whatever they told me to name it, G of X, yes? I don't know what I'm doing yet, but I know I'm going to have 6X. It's a horizontal, yes? Okay. By a factor of 1/6, followed by a translation of 3 units to the left. What do I do? Is 3 units to the left my H or my K?
H.
Why is it H?
H is the,
It's horizontal.
That's right. It's a horizontal. Left and right are horizontal, yes? Up and down are vertical, right? That's why I know that it's my H, okay? So, followed by a translation. So, it told me to do this first, yes? Then it said 3 units to the left. So, do I write +3 or -3? +3, because it's X minus H minus a negative is plus a positive, yes? Okay. To the left of, and now that's what I started with, the cubed root, right or wrong. So let me ask you this. If I wanted to leave it like this, can I just do that? Hello? Yes. I can write it like that, or I can write it like this. Everybody with me? Now, for consistent factors, and I don't know, we wouldn't necessarily have to do that for graphing wise, but just for consistency, guys, I would like for you to write your answers like this. Everybody with me? Questions? No? Okay, now I'm going to do a little throwback really quick. I'm just going to do a sketch. Everybody with me? Yes, no, or maybe? Okay. So I'm going to sketch the square root of X. Then I'm going to sketch the cubed root of X. Everybody with me? And let me put y equals. Okay. So if I'm going to sketch the square root of X, don't forget it looks like like half a check mark, yes? Now, I'm so not good at sketching a cubed root. A cubed root is like an elongated S almost. Everybody with me? So it comes, let's see if I can do it this way. I always turn my paper sideways. So I'm coming this way. There we go. So this is my cubed root. Everybody with me? Yes, no, or maybe? Now, notice that on the square root of X, yes, I have a starting point and going, right or wrong. That starting point, so to speak, is my vertex, like my H and my K. Everybody with me? Okay. On my cube, my turning point is my H and K. Everybody there? Questions? Okay. So we need to be able to recognize, hey, this right here's a square root. Hey, this right here's a cubed root. You with me? Okay. So real quick, I'm going to pull up Desmos, and we're going to look at some graphs and compare them, because it's easier when you guys can actually see those graphs, okay? Why? And I'm going to type it in fractional form because it's easier for me. Is that okay? Okay. So here's the square root of X. Everybody agree with me? And that looks like the sketch that I drew. Yes or no? Let's see if I can change this. Okay. So it's black. Now, we're going to compare that to the fourth root. Is that okay with you guys? Okay. Oops. I had, because we're going to have to identify some things in a little bit. I had to pay attention because I thought, okay, I don't want my students to have to graph all of these just to match them. Do you guys understand? We want some key points. And unfortunately, we can't use the vertex. There's no horizontal shift. There's no vertical shift in these, is there? So we have to pay attention. So here's what I'm going to ask you. What do you see different from the square root of x and the fourth root of x? Between the red and the blue, what is a key thing that you see different? Oh, okay, first let me ask you, are they exact? Okay, what's one thing you see different? One, just one thing. Tell me that.
Square root is going up higher.
Square root goes up higher, okay, so it goes higher quicker. I understand that, all right. But is that going to be easy to determine when I'm just looking at graphs? So here's what I'm going to tell you. Look here. Oh, wait, before I show you, let's do the sixth root. Is that okay with you guys? And notice I'm doing even roots. 2, 4, 6, okay. So let me just copy this, and then I'll change it to the sixth root. Here's what I'm going to show you. Notice, we all start at 0, 0, yes? Notice that the square root, and it goes hand in hand with what Aiden said, the square root, it's not as long right here. Would you agree? And then my fourth root is longer, yes? My sixth root is longer, yes? So what about the eighth root? It's coming. So when I say longer, what I want to say is I have a more flat looking right here. Yes or no? Do you guys understand that? Okay. So you're going to look for those things when I don't have a horizontal shift or a vertical shift to compare it to. You guys with me? You're going to look, well, hey, is this one longer than that one? Well, then, okay, this is going to be the square root. This would be the fourth root. Now, when you have something like the sixth root and the eighth root, you might have to plug in numbers and see, okay, which one's closer. Do we understand that? Yes or no? Okay. So now let's look at the cubed root, the fifth root, and the seventh root. Is that okay with you guys? Okay. Turn these off. I'm going to do the cubed root here, and you guys can see it's kind of an elongated S, yes? Okay, I'm going to do the fifth root here. I'm going to do the seventh root here. Now, before I actually go and graph these or turn my graphs on for the fifth and seventh root, kind of picture in your mind what you think the graph would look like. Is that okay? So I want you to take just, 10 seconds, 20 seconds, and I want you to picture in your mind what you think the graph of the fifth root of x would look like compared to the cubed root. You guys with me? Yes, no, maybe. Okay. Did it look like it? So it's very similar to how my square root compared to my fourth root. Right or wrong? Okay. My cubed root is going up faster, yes? But my fifth root, I'm longer here, yes or no? So what do you think about the seventh root? Okay, I have a question. Do you think that that's going to come down below here, or in between here, or above?
Below.
I think it's below. And what about this elongated?
It's gonna be higher.
I think it's higher when you say, oh, okay. You're saying higher up here. Okay. Okay, higher up here. Yeah. Okay, I got what you said. Oops. Was it what you pictured? Okay. Now I showed you these things because when it's at 0, 0, we have to be able to recognize some key factors so that we could pick a graph and go on, yes or no. You also need to have an idea, hey, all of these look very similar. Are you guys with me? Okay. So back to here. Here we go. This says, this says to use a graphing calculator to graph 1/2 y squared equals x. Well, okay, let's think about this. This is a y squared. Have we done y squareds before? No. 1/2 y squared equals x. What is a squared? When we see something squared, what do we think of? Not square root, not cubed root. Squared. We've worked with squareds all year long. What do we normally think of? Quadratic. Yes? Okay. What does a quadratic look like? Just if you were describing it to me. Kendall, if you were describing it to me, what would it look like?
A U.
A U. Okay. Does it always open up?
Yes.
Every
Oh, wait, no.
Okay, so it could open up or down, but it is a U. Absolutely right. It's going to go up or it's going to go down. It could be over and up. It could be over and down. Whatever. Yes? But that's okay. So, well, if that's what that looks like, what do you think this would look like? Because in a quadratic, we have y equals x squared. Right or wrong? This isn't y equals, is it?
Do they open the other way?
What other way?
Like, not different.
Oh, let's check it out, okay? That's 1/2 y squared equals x, yes or no? Now, you cannot type 1/2 y squared equals x in your calculators. Do you understand that? It just doesn't let you do that, okay? But this MOS does, okay? I have 1/2, it was y squared, yes? Equals x. What happened? It opens left and right, yes or no? So if that 1/2 was negative, what do you think would happen? It's going to go left. Okay. Now I want to show you guys something. Okay. I want every single one of you to pull out your calculators for just a moment. Okay. Pull out that calculator. I probably should show you this, but I'm gonna. Oh, I'm sorry. I'll get it. Sorry about that. Okay, everybody got a calculator? Everybody have your calculator? Yes or no?
Yes.
Okay, we're going to do this together. Does that sound good? Okay, let me pull up mine. I saw it earlier. There we go. And it doesn't matter if you have an 84 or an 83. This is going to work. Do we understand that? Okay. So we're going to pull this up. Okay. Now, what we're going to do is we're going to go to our y equals function. That's what's there. Everybody with me? Now, I have something else there, so I have to go down and I've got to clear everything out. I just want one thing on there. Everybody with me? Yes or maybe? Okay. Now, what we had was 1/2 y squared equals x, yes? What we're going to do, we're used to working with x squared, yes or no? So what we're going to do is we're just going to type in 1/2 x squared equals y. Is that okay with you guys? All we did was switch the x and y, that's it. Do you understand me? We're going to type that into our calculator, and I'm going to show you why. Okay? So, I don't care how you do your 1/2. I tend to use my parentheses because I'm lazy and I don't want a whole lot of keystrokes. You guys with me? So I'm going to type in 1 divided by 2, close those parentheses. I have my x squared. Yes? I don't have plus anything, that's all I have. Everybody with me? Okay? You can hit enter and go to the next line, doesn't really matter. You can leave your cursor on the same line. Everybody with me? Do? Okay. Now, no, I don't have to do that. So next thing we're going to do is we're going to hit our graph button, which is the top right button says graph, yes? So we're going to hit that. We're going to hit graph. Oh, that's up or down, yes? Okay. Hold your calculator right in front of you. Yes? Turn it to the right. So now I can't rotate mine, but now your graph looks like this. Yes or no? We've now graphed that. Do we understand? Yes or no? Questions? Okay. So we can graph it on here without having to do any algebra. Do you? Yes?
My calculator diagram.
Okay. So please understand that you don't have to do a whole lot there. Do we understand that? Yes, no, or maybe? eventually I'll show you how to graph circles using your calculator as well. Do we understand that? Okay? But when we're doing parabolas, regardless if they open left or right, we can graph it just like it is by rotating. Everybody understand me? Okay? You switch your X and your Y. Since that's positive, you'll just turn it to the right. If it was negative, which direction would you turn it? Everybody with me? Yes, no, or maybe? Okay.
I'm just gonna pop.
What, baby?
Make a square.
You missed it. Okay. All right. So now let's put our calculators up so I can have your attention. I do want you to play with your calculators, but not while we're doing this. Do you guys understand? Now, with that said, we know that the problem given 1/2 y squared equals x, we know we graphed it, that it's opening this way. Yes or no? The beautiful thing, and I'm going to go back again, about this is it's all the same. Do you understand me? A still determines your shrink or stretch, yes? Except it opens left and right, so it would be a horizontal shrink or stretch. Do we understand that? Yes or no? So, one thing that's different is since this opens left or right, this is not a function. Everybody understand that? It's a graph, but it is not a function. And I know it's not a function because it will fail the vertical line test. Everybody with me? Okay. But even though it's not a function, those rules still apply. Everybody got that? So, x equals a times y minus k. K goes with y, yes? Plus h. Squared. This is the equation of my parabola that opens left or right. Do we understand? A is not going to determine my vertical stretch or strengths. In this instance, it would be my horizontal stretch or shrink. Yes? Hello? Now, HK is still my vertex. Everybody with me? H is still my horizontal move. K is still my vertical move. Everybody follow so far? Now, real quick, let's talk about the axis of symmetry. When it opens up or down, my axis of symmetry goes right down the middle, yes or no? And that's a vertical line, x equals h, right or wrong? Is that going to be a vertical line, my axis of symmetry? What's my axis of symmetry going to be? It's going to be a horizontal line, okay? So my horizontal line, in this instance, right down the center, yes? So the equation of a horizontal line, axis of symmetry, is y equals whatever that k value is. Are you with me? Yes, no, maybe? Okay. So we have that. So identify the vertex and the direction that it opens. We did this, we looked at the direction that it opened with our calculator, but we should be able to identify it just by looking at it. Do you understand me? Is A positive or negative? Right here. Is A positive or negative?
Positive.
Positive. So does that mean if it opens left or right?
Right.
Right. Positive is right, positive would be up, yes? Negative is left, or negative would be down. Are you with me? Okay. So this opens, we're going to identify the direction that it opens. This opens right. Yes? And my vertex, HK is my vertex, yes or no? There's nothing grouped with Y. There's nothing tacked on the end. So what's my vertex?
0, 0.
0, 0. Not as hard as what it might seem. Everybody with me? Yes, no, or maybe? Okay. This says, okay, and we're not going to emphasize a whole lot on this. I'm going to throw some stuff at you. We'll do more on circles later. Everybody understand me? Yes or no? Okay. Now, any circle, each time, every time, all the time. Any circle. Are you with me? Okay. X minus h radius squared. Again, what do you think HK is? What?
Horizontal shift and
Horizontal shift and vertical shift. You're absolutely right. However, it's actually more than that. It's the center of my circle. Yes? Every circle has a direct center, yeah? Okay. So HK, I don't like the way that looks. HK is the center of my circle. Center of circle. My radius, R, is your radius. That is the distance from the center of the circle to a point on the circle. Do you understand me? Yes? So if I look at this one right here, they said graph it, which I will show you how to graph any circle in your calculators later. But I'm also going to show you how to answer this without having to go through all this keystroke in our calculators. Do we understand? First of all, let's look at x. What they gave me. X squared plus y squared equals 16, yeah? Is there anything grouped with x? Anything? No, nothing's grouped with x. I don't have x minus anything. I don't have x plus anything. So where do you think my h is? Okay, think about it.
0,
Somebody said it.
0,
0,
0.
0. Okay? There's nothing grouped with x. Yes? So what is the value of nothing?
0.
There is nothing grouped with y. So what is the value of nothing? So my center is at 0, 0 for this in particular circle. Yes? My circle's right stinking there, the center of it, right or wrong. Now, this represents radius squared, right or wrong. So if radius squared equals 16, what's my radius? How'd you get it? Square root of both sides. Square root of this side, that side, and it's 4. Why don't we consider a negative 4? I'm just curious, because normally when we take the square root, it's a positive 4 or negative 4. Why couldn't it be a negative 4 in this instance? Think about it. I'm going to measure from me to Caden. Okay? It's 4 feet. What's the distance from Caden to me? Why isn't it a negative 4 feet?
You can't measure negative.
There we go. We can't have a negative distance, can we? Yes or no? Okay. So that's why my radius is 4. So if my center is here and my radius is 4, 1, 2, 3, 4. There's the point on the circle, yes or no? Hello? And then 1, 2, 3, 4. There's a point on the circle, right or wrong? And then I go 1, 2, 3, 4. 1, 2, 3, 4. And then I draw in my circle. That's not too bad. Do you guys see what I'm saying? Yes, no, or maybe? Okay. So I'm going to twist this up just a little bit. Is that okay? And I'll be sure that I give it a pretty radius. Okay? Okay, where's the center of my circle?
-3, 2.
That's right. We can pick those out because we've done things very similar to it in the past. Yes or no?
Yes.
You with me? Right? Okay. So if my center is a -3, 2, what's my radius? 5. Radius equals 5. Everybody with me? Yes, no, or maybe? So if I were going to graph this in particular one, graph by hand now, mind you, not on our calculators, yes? If I was going to graph it by hand, here I am. I'm at -1, 2, 3, +1, 2. There's the center of my circle, yes? Hello? And there's 3, 4, 5. I would have a point here. And then, let's see, 1, 2, 3, 4, 5. I'd have a point here. I'd have 5 on this side over here, yes? And then I got 1, 2, 3, 4, 5. So I have it there. So this is what the circle would look like. Yes or no?
Yes.
Okay, so don't let things like that intimidate you. Everybody with me. Yes, no, or maybe? Questions? Okay. So, let's go to the next one. Here we go. This is the one that we are going to match. Everybody with me? Yes, no, or maybe? So, I don't know if you want to take A and then match it to one of those, or if you want to take one of those and then match it. How do you want to do it? I might need to make these slightly smaller. How do you want to do it? Do you want to match the numbers to letters or letters to numbers?
Letters, numbers.
Letters to numbers? Okay. There, is that a little bit better? Okay, letters to numbers. So we're gonna do A, yes? First thing I'm gonna ask you, is this an even root or an odd root? A? A's an odd root? Okay. Which one just has like a check mark? Okay, if we don't remember, let's look. I heard somebody say it.
Square.
Oh, I guess I took it off. Yeah, it is the square root. Everybody with me? Here it is. There's my square root, yes? And then my fourth root would be a little elongated here, right or wrong? Okay, and the sixth root would be a little elongated again, yes or no? Okay, and as this is a cubed root, my odd roots are like an elongated S. Everybody understand that? Okay, so we have those. Let's go back here. Here we go. Oops. Here we go. So this one, is it an even or an odd root? It's an even. Now all of these are square roots, right or wrong? So I don't even have to worry about elongated, do I? So I have to worry about horizontal shifts, vertical shifts, yes or no? Okay. So this one, did I move left or right? But I did go where? I went down. So I'm looking for a vertical shift down of how many units? 3. Okay. Which one has a -3 tacked on the back? Okay. We have a 5, 7, and 6. Now I can eliminate one of these right off the bat. Which one can I eliminate right off the bat?
5.
Why 5?
Because negative 3 is grouped with X.
That's right. -3 is grouped with X, which means it's a horizontal shift. Yes? So 5's gone. Okay, can't be 5. So I'm looking at 6 and 7. Which one is it, and again, why? Go, Aspen. Why? Why would it be 6 and not 7? Gotta have a reason. Can't say I guess. We have to know.
Because 7 would move left 3.
Right. 7 has something grouped with X. Yes or no? Means I have a horizontal shift. Right or wrong? Does this have a horizontal shift? No. So A goes with which number? 6. There's 6. Everybody with me so far? Yes, no, or maybe? Okay, so 6 is gone. Is that okay? Okay, so let's go with B. I'm going to ask you, do I have a horizontal shift? Do I have a vertical shift? So I'm looking for something with a horizontal shift only. So if I'm looking for a horizontal shift, is that grouped with X or is that tacked on the back? Okay, so I want something grouped with X. Okay, what's going to be grouped with X? What's my horizontal shift?
Negative 3.
Okay, my horizontal shift is left 3, yes? Is that going to be a +3 or a -3? So I need to look to see which one of these is the square root of X plus 3, yes or no? Which one is the square root of X plus 3?
3.
So this is 3, and I'm done. Yes? Okay. What about C? Do I have a horizontal shift? How many?
3.
Okay. To which direction? So is that a +3 or -3? Okay. Is that grouped with X or tacked on the back? So I need square root of X minus 3, yeah? And then do I have a vertical shift of any type? Okay, how many? Which direction? So is that a plus or a minus? Okay, so I need a square root of X minus 3 and then plus 3 on the back, yes or no? Which one of those? Is this as hard as you anticipated? So I'm gonna give you about 2 minutes and I want you to place the last 3. And when I ask you why, I need you to be able to tell me why. We have about 40 seconds left. Does anyone need those 40 seconds, or can we go ahead and continue? Can we continue? Yes, no, maybe? Okay. So, D. I want your answer for D, but you have to tell me why. Nikki.
I think it's 4.
Okay, Nikki says this is 4. Why?
Because the +3 isn't with the x.
Okay, so what's that mean?
It's a vertical.
Shift.
Yeah, vertical shift.
Vertical shift. Which direction?
Up.
Up. Okay. Now, why did you leave it like that? Why is it not there? Why didn't I go left or right? I'm just questioning.
It's not grouped with the x.
That's right. Nothing is grouped with the X. So for D, 4 is the correct selection. Everybody with me? Okay. Now let's look at. So we've got that one wrong. That one's gone. Okay. What about E? Let's go with Kaden.
I put 7
Okay. You put 7. Why?
because the -3, so on the end that's stacked on the back,
Okay.
you have to go
Down 3.
down 3, yeah, and then the +3 is grouped with X, so you have to go over 3.
Over 3. And since it's X and minus H, minus a negative would look like plus a positive. So Kaden is right. And if you wanted to say just process of elimination, this would be number 5. But also because X minus H would be 3, grouped with X, a horizontal shift. Yes? Okay, how hard do you think this is right now? Just right now. Okay. So, let's go on. Okay. All we're doing is describing the transformation. Oh, wow, we've done this before, haven't we? Yes or no? Okay. So we're gonna go from easy to not so easy. Is that okay? Well, actually, yeah. We'll go easy to not so easy. Let's do number 19. Yes. And we're gonna go in order. We're reading left to right. Do you understand me? Okay. Now, first of all, I want to show you only this one has a negative out front, yes or no? That negative out front means instead of going this way, I'm going to go this way. Everybody understand that? Is that right? I think so. Let's check and make sure. It might be a reflection over the x-axis, and I'm thinking that it might. So we're going to find out just real quick and make sure. I apologize, guys. Let's go here. Let's change that to a 1/2. Oops. and then I'm gonna stick a negative out front. Is that okay? Yeah, it's down. It should be a reflection over your x-axis. So after I drew that picture, I thought, I think I'm wrong, and I am. So it'll be this one right here. Everybody with me? Yes or no? Okay. I know what this other one is, but we're not doing this one today. So it would be reflection over the x-axis. And that's what you're gonna say if the first thing we see is a negative, the very first thing you're gonna tell me, a reflection over the x-axis. Do you understand me? Okay. Does this have any type of reflection at all?
No.
No. Okay? So we don't mention any type of reflection because all of our square roots are gonna go like that. Do we understand? Yes or no? Okay. So I don't have a vertical stretch or shrink, do I? Okay. Do I have a coefficient of x? No, so I don't have a horizontal stretch or shrink. You guys with me? Okay. So the next thing that we see is this +1. What's that mean?
Okay.
What?
It's your K value.
Is it my k value?
No.
It's my what?
H.
It's my h. What does h determine? Horizontal shift. So that's the first thing I'm going to say. I have a horizontal shift. Which direction? How many units? 1 unit. Because that's the first thing that I see. Because this is my parent function, right or wrong? Okay, first thing I see is a horizontal shift left 1 unit. Then what do I see? Okay, what's that mean?
Vertical shift.
I have a vertical shift where?
Up 8 units.
How hard is this? Not too bad. Okay, so now we're gonna jump to 21. Is that okay with you guys? Okay. Very first thing that we see is what? On 21. The negative. I've got it underlined. What's that negative mean? A reflection. Instead of looking like this, it's going to look like that. Yes? So the very first thing is I have a reflection, and here's where you have to be careful. It's a reflection. What axis is this? X. Over the x-axis. You guys with me? Okay. Then what's the next thing we see? Do we have a horizontal shift? Is there something grouped in the radical with x? So do I have a horizontal shift at all? So this wouldn't be in there. Do I have anything tacked on the back? What do I have? I have -1, which means I have a vertical shift. How hard, guys? Okay. So pick another one. Oh, let's graph 23. I know what it's going to look like. Do we understand that? And here's what I want to point out. That negative is not outside the radical, is it? That negative is inside the radical. Yes? You will have a reflection, but it won't be over what was that? 1/4 negative x to the 1/2 power. So this is 1/4, yes? And here was negative, right or wrong? Okay, picture in your mind what you think is going to happen, yes? We got it? It just went the other direction. It's a reflection over your y-axis. Do we understand that? So when your x is negative, it is a reflection over your y-axis, not your x-axis. Do we understand? Yes, no, maybe? Okay. So, go back there. Okay. Number 23. Very first thing we're going to write is a reflection over what? Y-axis. Oh, that's not the first thing we're going to write because 1/4 is the first thing we see, isn't it? So what's that 1/4 determine? That's my A value. Is that a vertical stretch or shrink, or is that a horizontal stretch or shrink?
Vertical stretch.
Okay, is it a vertical stretch or is it a vertical shrink?
Shrink.
Shrink. It's exactly what it appears. 1/4 of something would make it smaller, yes? Okay, so that would be our first thing. Our first thing is a vertical shrink, yes?
Yes.
Oops, R-I, okay. By a factor of what? Of 1/4. That's what we see first as a 1/4. Then we see our reflection, yes? Over the y-axis. Is there anything grouped in there?
No.
No. Or I mean here, anything grouped? Nothing's grouped. No horizontal shift. Yes. Do I have any vertical shift? So I'm good. Everybody with me?
Yes.
Okay. Now, when you come in tomorrow, you're going to have some of these that you're going to have to answer right off the bat. You guys understand that? Okay. This video will be posted on Classroom later today, so if you want to go back and look at it this evening, feel free to do that, okay? Have a wonderful day.